our last example here. What about y is equal to 4 plus 5x plus 9x squared plus 12x cubed plus 12x to the fourth, and all this is going to be over x cubed, and they want us to find dy over dx whenever x is equal to 1. So what they're asking for is the first derivative of y with respect to x. So the first derivative of y with respect to x they want us to find. Well, I'm going to try to simplify this stuff first if I can. So I'm not taking a derivative yet, so that's going to stay y. But I'm going to say 4 over x cubed, 5x over x cubed, 9x squared over x cubed, and so forth. So I'm going to write this as 4 over x cubed plus 5x over x cubed plus 9x squared over x cubed plus 12x cubed over x cubed plus 12x to the fourth over x cubed. Then I'm going to try to simplify because this makes it much easier for me. All right, cannot simplify the first one. So that's just 4 over x cubed plus this one I could divide the top of the bottom by x to the first, and I get 5 over x squared. Over here I'll get 9 over x once I simplify. Here I'll get plus 12, and here I'll get plus 12x to the first. Now, I don't like these right here, these x's being in my denominator. So I'm going to bring them up top here and give them negative exponents. So y is equal to 4x to the negative 3 plus 5x to the negative 2 plus 9x to the negative 1 plus 12 plus 12x. Very important. This is still y. I have not taken a derivative yet. All I did was simplify y, so I'm calling it y. Now that I have it in a formal multi, I'm going to use the derivative notation dy over dx. The derivative of y with respect to x. Now technically what I'm doing here is this. Technically what I'm doing is I'm saying, okay, I'm taking the derivative with respect to x of y here, and I'm really taking a derivative of both sides. So what does this give me? Negative 12x to the negative 4 minus 10x to the negative 3 minus 9x to the negative 2 plus 0 plus 12. All right, this I can shorthand. I can write as dy over dx is equal to. Now let me turn these back into positive exponents. So I'm going to bring that to the bottom. I'm going to say negative 12 over x to the positive 4 minus 10x to the positive 3 minus 9 over x squared plus 12. Now I found dy over dx. But what this is find dy over dx and evaluate it whenever x is equal to 1. That's what that notation means. Evaluate it when x is 1. So I'm going to write dy over dx evaluated whenever x is 1. So what does that mean? That means I take the derivative and everywhere I see x in it, I'm going to substitute in that 1. So I have negative 12 over 1 to the fourth minus 10 over 1 cubed minus 9 over 1 squared plus 12. I'm going to have to continue over here because I'm out of room. So that's negative 12 minus 10 minus 9 plus 12. Well, those go away, right? So what do you get? Negative 19. And that's all there is to this section. Homework should be fairly straightforward for this one.